Hard water versus soft water. And we want to start off with, what is hard water? It's naturally occurring water that has a high mineral content that typically comes from aquifers underneath the ground, but can also come from rivers and lakes as well. And it specifically contains dissolved salts of magnesium sulfate and calcium carbonate, among other minerals. It's water that's unrefined by a water softening system, and it just occurs through traveling through, like limestone, chalk, gypsum, those kinds of minerals in the soil, and it's absorbed through the ground into an aquifer. It's typically within the range of 120 to 180 parts per million, or 7 to 10.5 grains per gallon. So what is soft water? Soft water is going to be water that is lower or lacking in mineral content, and it's water that is refined via water filtration or softening system. And soft water can contain an excess of sodium or potassium depending upon what type of softening system is being used. But generally speaking, it's going to be between the ranges of 0 to 17.1 parts per million, or 0 to 1 grains per gallon. So what are the pros and cons of hard water? Magnesium and calcium in hard water are considered to be nutritionally beneficial, but there are other minerals that are going to be in hard water that can have very negative effects, such as iron or arsenic. If you are using hard water, they say that it's a really good idea to get the arsenic levels checked in your hard water. But you do have the benefit of not having to pay for or maintain a water softening system, which, can range anywhere from $2 to $6 grand, or more, depending upon to what level you want the water to be filtered down with. So the main thing about hard water is that it can clog your pipes and damage water-based appliances and cause staining as well as damage to your hair and skin. Particularly the chemical reaction that happens is one to where the calcium and the magnesium can absorb the soap, absorb the soap that is in the water, and then make it to where you can't really, it kind of turns into a film that doesn't really get off of your skin, and in that sense it sticks to your skin and then it dries your skin, which is not good. So the pros and cons of soft water: it's going to extend the life of your water-based appliances. It's better for your hair and skin, obviously. And if the water source is well-based, depending upon the type of system, they can also eliminate bacteria that can develop from within the well, which is a really nice feature. And but it does lack natural beneficial minerals. So, you're not going to be getting, say, the calcium or the magnesium that you would be getting from hard water, or maybe in small doses in spring water, but it is going to be free of the minerals that could be harmful to you. Can have excess potassium or sodium. Excess sodium, you can get high blood pressure, from having too much sodium, but you are going to save, a substantial amount of money if you don't get a water softening system, because it does cost money. So the effects of hard water: in many scenarios, hard water causes the buildup of scale when heated in the following electrostatic chemical reactions. So you have calcium over here combining with the carbonate to be able to make basically calcium carbonate, and then an excess product of H2O and carbon dioxide gas. But that calcium carbonate is not something that can dissolve. So it's going to be insoluble, and that's going to create scale buildup on, say, the inside of your pipes, around the edges of your faucet, that kind of thing. Similar with magnesium as well. So mineral deposits in the form of an insoluble precipitate known as scale occur from the ionic reaction. But let's see. There we go. Softening of water. So there are a variety of water softening systems in today's market. Each system varies in complexity and the chemical processes used to refine the water. Each system delivers a varied quality of water that is subject to debate but falls within the acceptable range of the parts per million, which I believe is 0.17 or less. So, salt-based systems. These are the typical water purification systems seen in most houses. Especially older houses as well. Compared to today's current standards, these systems are kind of old, but the water is purified via ion exchange. You basically have beads that are within a tank that are positively charged with sodium ions, and then what happens is that when the calcium gets into there, the 2+ calcium, charged calcium gets in there, what happens is that those ions are exchanged for sodium instead. And so then rather than having a bunch of calcium that's going to build up and, cause a bunch of staining and everything like that, now you have sodium ions in your water that aren't causing that problem. But again, there are other disadvantages associated with sodium. So reverse osmosis systems, these are the latest and the greatest. They utilize a lot of modern technology. This technology started back, I guess you could say with the Romans and everything like that. When they had aquifers and stuff, they would have the terrazzo filters that contained some charcoal in them, and basically what would happen is that water would travel through that charcoal and it would clean it to a certain level. But now we've actually mastered this technology, and we have these semi-permeable membranes that basically travel through these 0.0001 micron pores. I guess you could say 10 to the -3, 10 to the -4, something about like that. But it eliminates the needs for salt bags to be able to purify water, so at least you're saving money there as far as that concerned. Some of them are equipped with a UV sterilization feature, which is really nice because that's going to sterilize the bacteria from your well, which is very handy. And that's it. That is my presentation.